Okay, thank you very much. My name is Michinori Hatayama, DPRI Kyoto University. I'm a WENDI co-chair on data science. And today I will show the data science for disaster risk management and disaster response. So this is this figure shows the number of the deaths of the missing persons caused by natural disasters. So in Japan, in Japan, we have a big disaster in 1959 in Ise-1 typhoon. At that time, we have more than 5,000 people were killed in this disaster. But after this disaster, there were only small damage by natural disaster for more than 35 years. And after that, we had a great Hanshin-Awaji earthquake in 1995. So at that time, about more than 6,000 people would die. So at that time, there were a lot of the problem in disaster response. And of course, this number includes the victims of the second disaster. But if the effective risk information had been shared, the residents could have acted sooner and survived. So also the IT revolution started to gradually in 1990. So we will expect it. Innovative information technology has been expected to apply to disaster response and disaster risk management. So the data science is a study of the extracting value from ubiquitous data in our society. So under one of the hottest old and new areas. In disaster research, we have already used it as a statistical method. But as the innovation of information communication technology expanded in recent years, new types of data, such as location data of individuals and image from individuals, satellite, drones, have been able to use on demand. So our data science area is a cross-functional field, I think. And of course, basic data science lessons are distributed each special issues. But so the cross-functional field data science have already have to cover all of the areas. And of course, we have to add the disaster responses. So I show one example in Kumamoto earthquake in 2016. So most of the victims could not enter in designated refuge places because the capacity is not enough. So overflowing people gathered in space which will become undesignated refuge spots. So victims in undesignated refuge spots did not receive enough support of the food and goods in comparison with in designated refuges. So we propose a data science approach to solve this problem. So traditional approach, so most of the local officials walk around and get the information from the real field. But our proposal is get from the big data analysis of the population transition. So we use this type of mobile statistical spatial statistics. So it's based on the smartphone's position. And that is one of the analysis before and after earthquake. So prediction populations and 95% confidence interval if there were no earthquake obtained and by applying ARIMA model in time series analysis to the disaster before earthquake. So we get these values and bound curves. So this figure shows this mesh in which the population after earthquake exceeds to the upper bound of the 95% confidential intervals selects as a candidate including refuge spots. So if we apply this method to the real situation, so we can find a lot of undesignated refuge spots like this. So this one, this red mesh, that is the undesignated mesh we found from the data science. So this one is one of the example. So if we apply this type of analysis to the disaster response, we will provide a much richer result for the disaster response. So our target of WENDI data science area is the yellow zones, and now we are designing our programs. Thank you.